Okay, good morning, everybody. It's 8 o'clock, so let's get started. Let's see, I finished grading the exams for my other class last night, so I'll be starting on yours today. It'll take me a couple of days. It's not so much the grading itself, it's downloading your file, uploading it, grading it, and then sending it back to you. That takes all the time. But yeah, my eyes get so tired because I'm staring at the computer for hours. But anyway, I'll be doing that, and certainly by the end of the week, you'll have your exams back. Do have a homework assignment due Friday. It was posted on Blackboard on Sunday. Okay, and in fact, here it is. Okay. Just looking at these problems. So you got problems about finding critical numbers, the absolute minimum and maximum values of f, continuous function f on a closed interval. We talked about the intermediate value theorem, the mean value theorem, and the extreme value theorem. Okay, so problems on that. And then the last four problems are what we're doing right now, sketching the curve, but using calculus and the information from the calculus to sketch the curve. So yeah, that means you can use f prime to find the local minima and maxima and the intervals of decrease and increase. And then we can use f double prime to find the intervals of concavity, the points of inflection. We're going to finish the problem we started yesterday. The last four problems are going to take time. Okay, the rest aren't so long. The last four are long. So you're going to want to get started on those. Next week, I'm going to give you a few more curve sketching problems. Yeah, they're just going to take time. So you can get started early. The homework, don't wait till the last minute. It's not designed to be doable in a couple of hours. It's designed so that if you work on it all week, you'll be in good shape by the end of the week. And hopefully you will have learned what you need to learn. Let me start recording. Okay. Any questions from any of you? Okay, let's go back to that problem we were working on yesterday. The one where I took the derivative and it looked really messy, and I hope you don't hand in homework that looks like that. Okay. In fact, I rewrote it. Okay. Okay, yeah, we were looking at this function. F of x is x to the 2/3 times 6 minus x to the 1/3. And that function has domain all the real numbers, because you can take the cube root of any number. Okay, so we spent a fair amount of time getting f prime. And okay, here now, not only do you need the derivative of the function, you need it expressed in a nice way. And for derivatives, we want to find all the critical numbers. Finding all the critical numbers means you need to have the derivative written as a product, if possible. It's very important to find all the critical numbers. The critical numbers give you places where things can change from increasing function
Miss Kennedy, is everything okay over there?
Anyone else want to make the best of the situation while we figure this out?
What do you mean?
I don't know. Is there anything you guys can think of while we're trying to get this all sorted out that we could do? Maybe discuss amongst ourselves what we know for a fact and what we're still having some trouble on. Even though she can't answer us right now, maybe someone else in the chat will know your answer.
Oh, great. Terrific. Okay. So let's turn it on and off.
Everything fixed?
There's still no sign of Professor Kennedy. I'll try again.
You guys still there? I'm sorry. No, just okay.
Yeah.
I don't know what happened. So how long was the audio off?
Be about 24 minutes now, I'm afraid.
The whole time. Okay. So Mr. Miller, thank you for sending the email. I finally got the message. Yeah, I can't see chats when I'm sharing my screen. So the
whole screen was also frozen, by the way. It was stuck at 8:05.
Okay. Well, let me go back to the problem and let's see, go through briefly with sound this time, I hope, what we did. Okay. I am sorry about that. Okay, so first time it's happened in this class. In fact, that's the first time I've lost audio ever. Don't know. All right, so how many of y'all are still here? Not many. Well, I'm going to keep going. Okay, and am I still recording? Yeah. I hate to waste a whole class. You know, whenever that happens, please just okay. It was really good if I know that it happened, first of all. So sending a message to, yeah, if you send it to my Gmail, it pops right up on the screen and I can see it.
Yeah, I had sent you one a couple minutes after it first went out, and I was sending you one right as you joined back in.
Okay. Well, I guess technical difficulties are a part of this online thing, but that makes every day more important and not wasting time more important, because you never know when, like it or not, everything is going to kick out. Okay, so we were working on this function. F of x is x to the 2/3 times 6 minus x to the 1/3. Domain is all the reals. We spent a lot of time yesterday getting the first derivative in a nice form, and we got finally f prime is 4 minus x over all of x to the 1/3 times 6 minus x to the 2/3. Okay. Then we need our second derivative in a nice form. Okay, and I was working on that this morning. I made an error someplace and I couldn't find it. I was hoping I'd have time to go through it with you all to find that error. But okay, the second derivative in a nice form is minus 8 over x to the 4/3 times 6 minus x to the 5/3. Okay, so working on the first derivative, you get 3 critical numbers. And this time you get 2 when f prime is not defined, when the denominator is equal to 0. So 0 and 6. And you also get 1 when f prime is equal to 0. That's at 4. That gives you 3 critical numbers. And that means 4 intervals to check. And looking at a number in each interval, you find that f is positive on interval from minus infinity to 0, so it's decreasing on that interval. No, f is negative. F is negative on the interval from minus infinity to 0, so it's decreasing. It's also negative on the interval from 4 to 6 and 6 to infinity, so it's decreasing on all of 4 to infinity. it's increasing on the interval 0, 4. So, okay, because it goes down and then up, when it goes through 0, you have a local minimum at 0, which is equal to 0. And since it goes, oh, stop that. Since it goes up and then down, when it goes through 4, it has a local maximum at 4. And okay, it's a positive number. It's a little bit bigger than 2. But all right, so just the first derivative information tells you a fair amount about the graph. We're going to get a refinement of that with the second derivative. But basically, we know now that the graph is going to, okay, come down. Oh, now my pencil's not working. It's going to come down through 0 and then go up, hits a max at f of 4, and then it comes back down forever. Okay, so we're going to get more about how it curves with the second derivative. And there you're looking at your second derivative information. Okay, so I wrote down the function again and the second derivative. F double prime of x is not ever equal to 0. The only way a fraction can be equal to 0 is if its numerator is 0 and the denominator is not. The numerator is -8, that's never 0. Okay, so you don't get any critical numbers for your second derivative that way. But you do get 2 places where f double prime is not defined, at 0 and 6. And okay, I was going to check these intervals. And my pen's not working, so let me see if I can. I don't know, maybe something happened with my iPad. I'm going to dock it for a minute here. See if that helps. Oh boy, if my iPad goes out, I'm in deep trouble. Okay, that's right. All right. And okay. All right, so f double prime, well, you've got a negative at minus 1. Minus 1 to the 4/3 is positive. 6 minus -1 is +7. That gets raised to the 5/3, but that's going to be positive. So we're going to get a negative for the second derivative on that interval. And that means that the graph is concave down. Okay. Between 0 and 6, say at, how about 3 is in there? Okay, we still get negative on the top. X to the 4/3 is always positive. 6 minus 3 is +3. That's positive. So it's still negative. And that means that it's still concave down. Okay, so no change in concavity at 0. After 6, say at 7, you would get, okay, negative on top always. X to the 4/3, always positive. 6 minus 7 is -1. -1 to the 5/3 is -1. Okay, that's negative. So that's going to be a positive number. So concavity changed at 6. So F is concave down all the way up to 6. F is concave up from 6 all the way up. Okay, so we have one point of inflection. That's where the concavity changes from, and in this case, from down to up. The point of inflection is 6, F of 6, okay, which is not a nice number. Oh, yes, it is a nice number. Excuse me. Because that's going to be another place where F is equal to 0. And remember, you go back to your original function. Yeah, to get your F values. Okay, so we have a point of inflection. So what do I get now for the graph? It's a little awkward. Okay, you've got, no, it's concave down on both sides of 0. But 0, 0, okay, you get a local minimum there. Let's sketch sketch the curve. F of 0 is 0. F of 6 is 0. And 4, okay, that gave you a positive number. It's a little bit bigger than 2. But now F is decreasing over here, decrease in it, then it starts increasing over that side. But it's concave down the whole time. Okay, so what does it look like? It's got to come in like that. And it's got to stay concave down until it hits 6. Okay, so concave down, concave down. It changes to concave up when it passes through that 0.60. So now it looks like that. So there is a really pretty nice picture of the graph that we got from looking at the first and second derivatives. Any questions? This one, there was a lot of work involved and just getting your first and second derivatives, not just getting them, but getting them into a nice form so you could find all the critical numbers and get a really nice sketch of the graph. So yeah, that took some time. You guys that are still hanging in there, do you have any questions? I guess not. I probably should stop since most people gave up and left. Yeah, whenever this happens, it happened once in my other class. Well, there, everything cut out. But I'm going to come back. Okay, so if you'll stay connected, I'll be back. What I usually have to do is to restart my iPad, and I also reboot my Wi-Fi. Yeah, I'm learning not to panic at least, but I don't know. These things happen, and I guess if this happens very often, I'm gonna go scream at Spectrum. That's where I'll get my internet through. Okay, questions, guys? Sorry about the interruption.
It's fine.
It's
No one
okay.
can know the internet issue.
Okay. Yeah, the only thing that got through to me was Mr. Miller's email to my Gmail account. So let me give you that email just for the future, okay? I'm going to put it on chat.
Okay. Another two things. One, on your image, there's a set of Wi-Fi bars, and they're constantly flickering from white to red to yellow. So I think that's your connection stability.
Okay.
In terms of everyone else.
Okay.
And when you were kicked off, one of the students actually got freaking control of the room.
Right.
Boom.
I see that. I see that. Email for Wi-Fi problems. Mine Wi-Fi problems. KE. Where's my at? Over there. Okay, Britain. So is that usually the case that the Wi-Fi is flickering?
I honestly have no idea. It's just a theory.
Okay.
I've never used Zoom before this year.
Yeah, well, me either. Me either. I'm not so sure it's Zoom's fault. I don't know. I guess maybe one thing I could do is to upgrade my Wi-Fi. I'm not sure that would solve the problem.
Yeah, I have no clue. Usually when connectivity is going down, the bars blink out and in. And so for the reason, so it going red to yellow to white is something new to me.
Well, I don't see any bars at all on mine.
Yeah, it's only on the person who's currently on the screen for everybody else. I was like, is my image, is the word Britain on the area where the screen image is?
Okay, Britain.
Like, is my picture frame on the screen? I know it's blank and all.
I'm checking right now.
Mm-hmm.
Yeah, you're there.
Just like right now, Cassie Libby popped up on mine, and he's got the same thing. The person who's currently whose image is enlarged at the moment is the person. It shows their name and the bars next to that name.
I don't see that. Okay, and I always switch. Okay, well, I'm the host. I don't see what you see. Mr. Miller,
I think that's only for people who are showing their faces, because I see it when you're on screen, Professor Kennedy, but I didn't see it when Britton was.
Okay, yeah, I know that the person who's got the camera on will be on the first screen that I see. The ones that have the cameras off, or I can flip through. But yeah, it prioritizes the one with the camera on. Mr. Miller, are you still there? I guess not.
Yeah.
Oh, you are. Okay, well, thank you for that email.
Oh, no problem.
I would have gone the whole class without knowing. Oh,
Yeah, I was trying to talk to the students, and then I guess they couldn't hear me, so I just tried to send you a message quick and see what was going on.
No, we couldn't hear a thing other than the other students in the call. A couple of people spoke up, and you couldn't hear us at all either.
No, I didn't hear anything. A couple of messages popped up, because yeah, I didn't hear anything. I thought it was just me, and then the other students said, can you hear Dr. Kennedy? And everyone was like, no. So
no, it was me.
To be honest,
I'd
At
leave
least on my
if,
side,
up in
I
the waiting room, and
Yeah.
then that didn't work. So I just sent you a message. Somebody sent, I think Melissa sent me a message on email. So I just, sent you one quick and
Okay, well, I need to figure out what to do about this kind of thing. Yeah, uh, it did work when I rebooted everything and got back in, but that takes a little bit of time. So okay, the first thing is I need to know definitely if something's going wrong. And then if y'all just be patient and wait, I'll get back as soon as I can. Yeah, the joys of technology. Oh, well, without which we wouldn't be having any kind of class at all, I guess.
To be honest, I always prefer for a piece of paper because a piece of paper can't die on you middle of class.
I know, but I could die if I were in the middle of class right now. I'm very high risk. Yeah. Okay, Mr. Flores,
That's not what I meant. I would never want you to risk. I would never want anyone to risk their life to do something.
Well, yeah, that's why I'm not even trying one of the hybrid things. And in fact, that nobody's back to full online, full in-person classes at this point. It's too dangerous. It's too dangerous for everybody. Yeah. Okay, the video should be, the recording was going the whole time. Well, I don't know what the recording got. It might have frozen too. I don't know. I will check it out and I will see if I can figure something out about how to handle this better in the future.
If
But why don't we
if every student's one didn't work, then we know for a fact Matthew Flores didn't get more than what was covered here. So his YouTube video will not be much help.
Right.
So.
Right. The question is I'm recording on Zoom too. I don't know if that was be much help because it might have frozen also.
Oh, it should be from your end, so it might be okay, but yeah, someone should double check and email you immediately.
Right. I think the problem was with my my Wi-Fi, not with anybody else's. So, well, we'll see. The note should be available. Okay, that will be fine. But anyway, okay, I'm a little flustered. let's end class for today, and I'll see you tomorrow. And okay, I think I'm going to move on from that problem. I do want to show you some more curve sketching problems before we leave this topic entirely.